All right, so for our 4 p.m. session, we have Benedict and Michael. And the session title is So Long and Thanks for Audi SDK Meet Trixnity.
So thank you for all the hitchhikers who made it here. Thank you very much. I hope you all brought your towels. So we can do a deep dive, or not so deep dive, into all the SDKs. At least we try to, and with the focus on Trixnity. So we want to begin with who we are. So my name is Michael. I'm a full-stack developer, and also I worked like 10 years as an IT consultant. I'm one of the co-founders of Connect2X, and I hand over to Benedict.
Yeah, I'm Benedict, the main maintainer of Trixnity, and I'm a full-stack developer too, and I have many experience with Kotlin and the Matrix ecosystem itself. And yeah, maybe we start navigating through the Matrix verse. If you are starting a Matrix project, you mostly start with, okay, what purpose do I want to fulfill? Is it a server application? Is it an application service, a client, a bot? There are so many possibilities. So if you're choosing an SDK, you have to look at the first stage, okay, which SDK fulfills this requirement? And the next step would be where should it run? Is it a server application, or is it something that runs on your mobile device? If you're choosing an SDK, this is important too. And next would be features. So the one SDK is capable of this feature and the other of the other feature, and you must find an SDK that have all the features that you need for your purpose. And yeah, performance is also a point, because if you have a slow SDK, then it's not fun. And yeah, if you have done that, then you are at the end of the Matrix verse. Yeah, now some hitchhiker's guide to choosing your multi-platform Matrix client SDK. For example, there are basically 3 SDKs that are really multi-platform in the ecosystem. There is the Matrix Rust SDK, there is the Matrix Dart SDK, and there is Trixnity. And licensing is very similar, all are open source. The Dart SDK also has copyleft in the license. And we have 3 different languages, Rust, Dart, and Kotlin. And each platform also have all the target that we need. With Rust, you compile to native code, which can run basically everywhere. And with Dart, you can cross-compile and restrict with Trixnity too. So basically, each SDK supports all your platforms that you need. And the next thing would be, okay, when I want to use this SDK, but I'm maybe a Kotlin developer, does it have some bindings? I need to call this API. And yes, the Rust SDK has Kotlin bindings, Swift bindings, Python, Ruby. The Dart SDK has no bindings. You need to use Dart if you want to use the SDK. And basically it's the same for Trixnity. Theoretically, it's possible to export bindings. Kotlin is capable of that, but we've done it. We've not done it yet. And regarding extensibility, the Rust SDK allows to add type-safe custom events, Trixnity too, and in the Dart SDK is more like, okay, I have a JSON and I do some JSON magic to create a new event or read some properties of an event. And also important is reactivity. All 3 SDKs have some sort of reactivity. In Trixnity, everything is reactive. Every data that you can receive out from the SDK is reactive, so you get future updates. In the Dart SDK, there are some helpers for some purposes, but basically, usually you use some sort of, okay, the sync is ready, now load the new data that is in the database, which is not very efficient. And also the Rust SDK has many observables. So there you run not in this problem loading everything from the database on every sync. Yeah, regarding databases, it's exchangeable in all 3 SDKs, but the Rust SDK has not really offline support yet because timeline events are not stored locally, they are in memory. With Dart SDK and Trixnity SDK, you don't have this problem. And the Trixnity SDK also has a reactive cache on top, which makes it a bit faster, but like I found out today, the other 2 have that too. Media is streamed in the Trixnity SDK and the Rust SDK, which is important if you're downloading a 4 GB file. You don't want to have that in memory, which is happening on the Dart SDK. And very interesting part is if you're implementing a messenger, you may need some UI helpers. You don't want to be at the level of Matrix and calling Matrix APIs to form your UI. You need some helpers to implement a client faster. And there are some in the Rust SDK, room list, timeline, sync, and that stuff. But in Dart not, and in Trixnity, there is a really high-level representation for a messenger that's named Trixnity Messenger, and that will be the second part of the talk today. Yeah, now the basic question, why another SDK? There are so much SDKs, but when I started back in January 2020 to discover the SDKs, do this Matrix World experience from 2 slides before, there were no real multi-platform Matrix SDK that fulfill all the requirements for implementing a good Matrix client. And there was also the problem with custom events. And I like custom events, trying out stuff with Matrix because it's so extensible. And Matrix itself, but not the SDKs. And I wanted an SDK with a generic application purpose. So with Trixnity, you can implement server applications. Actually, there is someone who is implementing a server right now with Trixnity. But you can also implement clients or bots, application service, so you are not limited by the SDK like some others do. Yeah, why Kotlin? Because it's a cool language, basically, and has wonderful multi-platform capabilities. You can write very much common code. Basically, in Trixnity, more than 99% is common code, so you don't have platform-specific code. It's compiled to each platform. But if you need platform-specific code, it's made very easy for you. It's baked in the programming language, and you have access to all the APIs on your platform. You can call from Kotlin C-libs without leaving Kotlin, or can call Android APIs or browser APIs, and this is really cool. And you also can import libraries from the platform-specific ecosystem. For example, in the web, you can import NPM libraries, which is also really cool. Yeah, and you have coroutines to make everything parallel and processing sync really fast, which we are doing. All the threads you are having doing the sync, and you can process even the initial sync with 10 megabyte or more in a few milliseconds. And yeah, everything is reactive. So if you get data, you get a flow. It's in Kotlin a flow, and this makes implementing UIs really cool because your UI reacts to every change that is coming from a sync. Someone changed the username is changing the UI, and so on, and so forth. Trixnity is very modular. As I mentioned, you can implement server stuff, application service stuff, client stuff. You can also only use the crypto stuff if you want. They are all their own modules, captured in its own and tested as unit tests and integration tests and so on. And if you are implementing a client, this is the most advanced feature of Trixnity. Right now, it's basically very high level to do something. If you write send message, you don't need to consider it this in an encrypted room or not. Did I have sent the Megom session to the other devices? It's all done in the background. There's an outbox, so you don't even have to worry that the message that you send is lost when you close your messenger, is stored in an outbox and sent later. And yeah, the next big thing that we introduced last year is Trixnity Messenger. And it's still an SDK. It's not a messenger like the name. It's an SDK, and it allows you to implement clients, even messenger clients, even simpler, because you don't have to know any matrix knowledge. You can just implement the client, and then I hand over to Michael.
Yeah, thanks. So we saw lots of layers in Trixnity, and I will introduce even more layers. So it's layers and layers on top of layers. So yeah, cosmic oopsies. Some of those layers were discovered by error, or maybe by accident. We stumbled upon them during our design. When we implemented the client, we quickly realized that implementing a UI on the SDK level, on the matrix SDK level, is really painful at some point, because you need a much higher abstraction sometimes if you want to iterate fast. So if people say, well, you can just use this and this SDK and then you can start implementing your client, it's like, yeah, kind of. But on the other hand, you need to do lots and lots of stuff yourself. So we discovered by accident this view model approach. We used it internally, but then we realized, wait, that's another layer we can extract, and then others can use it and implement their own UI layer on top. So at the bottom, we have a model. This is our matrix model. This is where all the SDKs are situated. So Lars SDK, Dart SDK, and also Trixnity. And we you can put a UI on top of it, and yeah, it could work. And we introduced this middle layer with the view model, with data binding to the UI and callbacks and data binding for information flow back. And we found it really useful. So kind of architecture you see here, Trixnity at the bottom, it's matrix, all the APIs, decryption, etc., what you saw before. Then it's Trixnity Messenger. View model, think of it like if you have a messenger with a room list, you have a room list view model, and it has all the aspects you expect from a room list. So there are like rooms sorted and listed, and they are updated accordingly. And then you have room list elements, which have maybe a room picture and a room name and maybe a last message, and so on and so forth. And every part of your UI can be described in a view model and is pre-computed for you, and you just have to paint it on top. So you can, since we use Kotlin multi-platform, you can use nearly every reactive UI technology to consume those view models and then paint your UI on top. So we have some examples here: Compose JetBrains, which is now, and Compose Web, which is now called Compose Multi-Platform. It's a bit older, this one, Swift UI, and you can also do React in Kotlin or in JavaScript, and it would work. So, but then when we have this view model layer, we also thought about extensibility. Benedict talked about extensible events in Trixnity, but also here we want you to customize those messengers. So, for example, the room list has the feature of sorting the room, filtering rooms, and the room list element has a last message. And besides other stuff. And then you want to, in your own messenger and in your own UI, you want to change the room list's behavior. So you change the room list and you say, well, I changed the sorting algorithm. I don't like it where it's sorted from last message. Maybe I sort it with direct rooms and then group rooms, like it's done in Element, or you have some different sorting algorithm, and you can do it. The SDK is built from the ground up to have such an extension mechanism and to do that. Or you could completely ditch the last message and say, well, I have completely new my room list element, and this implements a topic, displays some topic or something else inside the room list. And you can go even further. Because it's so extensible, this UI, pre-UI layer, so to say, you can also extend itself and build your own messenger logic with it. So we are a company, we're building a TI messenger. So we have a matrix messenger as our base. This is Trixnity messenger. And then we have a TI messenger layer on top, like Trixnity messenger base, which is split up into a Pro and an IPA version. If you don't know what those words mean, don't worry, but we can add more and more layers and even more layers, and we can specialize our client further and further and further. And then you can have a UI that consumes these view models, and for example, the Trixnity messenger UI, which is a messenger UI that can be white labeled. And for some of you who were in my talk yesterday, you saw Tammy, which is a messenger we implemented that is the white labeling of this messenger. And our product we developed for the German healthcare system is Timmy, which implements the UI of the TIM logic. So yeah, and this is where I hand over to you again.
There are already some projects that are using Trixnity ourselves in Tammy and our TI messenger Timmy. But there's also a home server implementation I mentioned earlier. There's another Android matrix client. It's also very early stage. There is a Mensa bot, a very German word, I guess, Mensa. But Defugs are also implemented some other cool projects like a reminder bot or a matrix join link bot that is really cool. There's also an SMS matrix bridge that is running on your Android and acts like a bot, not an application service, and bridging your SMS messages to Android, which is also really exciting. Yeah, and just a short demo. We mentioned Tammy, and I can show it to you. This is a desktop version. It looks like a simple client that you know, but it's native. It's not a web view or something like that, not an Electron app. It's a native application that is running, and yeah, that's why it's running so smooth. But you can also run it in the browser. It's looking the same. The UI is simply the same code, and it's running on another platform. And you can also run it on mobile. Then it's looking just, yeah, so on mobile. And same, so mobile, it means Android currently, but theoretically, iOS is also not far away. We just haven't the time to implement the iOS part. But it's
notifications as well?
An Android notification as well, yes. And yeah, you can try it out. The link is here, Connect to X, Tammy on gitlab.com. And thank you. We are open for contributions in Trixnity because currently we are, basically I am the only maintainer for Trixnity. Trixnity Messenger is a company thing, but the Trixnity project is an open source project that is funded by Connect to X basically. But it would be cool if there were more contributors. So please join us. Thank you.
Thank you so much for the attention. Does anybody have any questions? Yes? Don't panic. We have a lot of time for questions.
Yeah, thank you. Just one question. Did you implement a using proxy in the SDK Trixnity or not?
Currently not. We try to implement only stuff that is really in the matrix spec. So basically everything that is in the matrix spec run.11, despite the call stuff, because we know that there is a huge refactoring of the spec with a new matrix RTC algorithm. Yeah.
But There exists a proxy that is implemented with Trixnity. It's used in the TI messenger space. So since Trixnity also knows how to talk server to server, we used it to implement a proxy solution for TI messenger.
Okay.
More questions? Yeah.
You mentioned that it supports encryption. What library are you using under the hood for that?
Currently, it's still libOlm because there are missing CABI bindings. That would make it a lot easier to implement bindings to Kotlin. But we are investigating to introduce Vodosemark and Trixnity.
Are there any native crypto libraries in Kotlin, or are you going to have to link against something like Vodosemark?
There is no really multi-platform implementation for crypto stuff, but you can basically use the platform-specific stuff. So on iOS, there are crypto APIs. On Android, in web, there are subject crypto in the JVM too. And we are using that, for example, encrypting media, or the key backup stuff where you are encrypting some keys. Yeah, so we are using that, but doing it completely in Olm would mean for us that we need an audit, because the TI messenger needs an audited Olm implementation, and so we don't do that.
Thank you.
Further questions? Somebody? Okay.
No. Can I just find the APK somewhere? Yeah.
Nope.
Yes.
Can I find the APK somewhere, or do I have to build?
Currently, you have to build. We are releasing an APK Windows, Mac, and Linux download in a few weeks. But
in a few weeks, okay.
Yeah, 1 or 2 weeks, I guess. Yeah.
Cool. And I think there was something that I wanted to understand about WASM. You mentioned that the other SDKs, the Rust SDK doesn't support it.
It supports WASM too. It's like a native target for Rust. Yeah.
I think in the talk before there was something about that being a problem, like using Rust in web.
Yeah, but it's more binding problem.
Okay.
Binding all the APIs to the JavaScript API, I guess. But okay. I'm not a Rust developer, so.
But in Kotlin that would be possible.
In Kotlin, currently we have cross-compilation to JavaScript, so it's just a JavaScript file that is loaded in your browser. But WebAssembly is also a target for Kotlin, but not yet for Trixnity, because there are some libraries that don't support WASM yet, but I guess it's in a few months it will be there.
Okay, cool, thanks.
More questions? We still have a bit of time. No? So I'd like to thank you, the speakers, once again.